So I wanted to make a point about the homework for the face drawing program. Did anyone look at the assignment already? Okay. Christina asked a question last time. I thought others might have as well. I haven't heard from anyone else, but why would we want to submit? So we have three arguments that we want to pass to the function: the center, the size, and the window. So what is the purpose of the size? Are you guys clear on that? Or?
Size of the face or size of a certain part of the face?
Actually, it could be both. So that's what I wanted to say. So the reason you want to pass in the size is because you want to determine the circle for the face. And then what you can do is you can take fractions of the size of the face for the circles of the eyes, and the mouth could be like a half circle or something like that, right? So you can use fractions of the size you input for the face for the other measurements. And that this would also allow you, since you're putting in a different size, to have different faces when you're calling the test function. All right. So I'll let you work through this, and maybe you have some other questions to answer. Otherwise, for tonight, we're going to learn how to make decisions with Python. So we have our program. Do you remember we had a program where we converted Celsius to Fahrenheit? And so we're going to enhance it so that if certain weather conditions are met, so let's say it's over 90 degrees or hotter, then we're going to, this will be a condition. And if this condition is met, then we're going to print out to the user, bring a sun umbrella or wear sunscreen or one of these messages. And then if the temperature is, say, under 30 degrees, we're going to alert the user again and say, make sure to wear snow boots or dress warmly. And then we're also going to learn, these are just two possible paths that you can take in your program, how to enhance our programs further and then make multiple decisions. And this is another standard structure. I will show you tonight how to do it in Python, but the next class you take, you're also going to encounter it. Every language has its own decision-making syntax. Who is anyone taking Java next quarter? All right, so I'll see you in the Java class, and we're going to learn the same thing, but with the Java syntax. And you'll see how it's much easier the second time you take a language. It's just how it is, no matter which language. And is anyone taking JavaScript?
Oh, that's the one.
Okay, yeah. So it's common to think that Java and JavaScript are one and the same, but they're different. And in JavaScript, we also go over the JavaScript way of making decisions. Okay, so let's get started with our material for tonight. Oops, I don't have the projector on here. Oops. Oh, and so this will be the first part of tonight. Is going to be how to make multiple decisions. And this statement right here actually shows you the Python structure. It's a little bit different in many languages. The middle part here is else if, but in Python we have the elif statement. And I think probably not tonight, but next time we meet, we're also going to talk about exceptions. So that's another core topic that you would cover in any language, and we'll talk about if something unexpected happens in your program and you don't handle it, what is going to happen? It's going to crash, and it's going to be a bad user experience. You might lose data. It's not a good thing. So you want to try to handle the exceptions, and we're going to learn exception handling techniques with Python. Very, very useful. And also, as we talk about decisions, we're going to talk about the Boolean data type, because when you make decisions, the decisions are based whether a statement is essentially true or false. So it comes down to a Boolean. And then we will go through an exercise to try to design a program where we will come to the conclusion that the decision making is the most optimal way, the most optimal algorithm to implement. Okay. So we know that when we write when Python runs through a program, what is the sequence? Is it sequential, or how does it work? What is the entry point, and then what is the sequence of events? And maybe we haven't talked about it, haven't we? So the entry point for the program, do you want to?
I don't know, I just couldn't read
Oh.
because you're.
Okay, how is that?
Yeah, that's perfect.
All right. So the entry point to the program is going to be the main function. So if you have a main function, that's where the execution flow begins of the program. And then essentially items are executed sequentially. When the interpreter, I keep on saying executed, but I should say interpreted. When the Python interpreter sees a print line, it's going to print. When it sees calculate x plus y, it will do the calculation. So it's sequential up to a point that if we need to change the sequence, we can do this with decision statements, right? And with decision statements, what we can do is you have a fork in the road, and then instead of just keep on going, now you decide, I have two options, and based on what is the true statement, I'll go, left or right. So this was the program, to refresh your memory, from a few chapters ago, the convert program, which converted Celsius to Fahrenheit. It was written in the main function, and we asked the user for a Celsius temperature. You remember now input and float, right? Just as a quick review, why do we have this float here? We are converting, but we're not converting a number. We're converting something else.
A string?
It's a string. So you need to remember, and this is important, when you're getting input from the user, the input comes as a string. And then by applying float, you're converting the string to a float, to a number, so that you can now do math with it. And the float is indeed, as you both said, with decimals. Right? And then in the main function, then we're going to calculate, there is just a standard formula you can get off the web. 9/5 times the Celsius degree plus 32 will give you the Fahrenheit. And then we print out the result. So this was one of our first programs we did. But then as I already mentioned, let's see how we can change it up to make it so that we give some more sophisticated information to the user based on conditions such as the program. And so what do we want to do is the following. This is our pseudocode here. We still want to input the temperature. We want to do a calculation. So we have IO input processing output. And with output is going to be conditional. The condition is going to be if the Fahrenheit temp is greater than 90, then we print a statement. That's the only time. So if the temperature is 35, we will not be doing this. And if the temperature is greater than 30, we're going to print or should be less than 30, we should print a cold warning, right? If it's colder than 30, print a cold warning. So this should be reversed, right? All right. So this is a flow chart which is commonly used for describing decisions. So it's a very convenient way. If you're a visual person, you can even draw your own decision flow charts. So is the Fahrenheit greater than 90? Yes, then we do something. And then no, is Fahrenheit less than 30? So again, this is incorrect. So it should be, I need to go fix it. But if the Fahrenheit is less than 30, then we print the cold warning, and then we exit. Right? Make sense? And I always tell the students, Mike Sinkula has a drinking flowchart decision maker on his office, so you can go and examine that for more decisions. Do you know?
The way the symbols are set up on that flow chart, it's like less than 90 or more than 30 or so on and so forth.
Right.
But that does not include 90 or 30, right? Because it's not less than.
It's not less than or equal. That's right. So we're going to learn about several different options, whether we want to include the range or not include the number in the range. And I'll show you the relational operators to make that happen. That's well observed. In this case, Here we were just saying less than, so if it's 90 or greater than, then if it's 90, it will not trigger the message. And in fact, it's an interesting, this seems like a silly app maybe, but you know, there are rooms where there is a lot of equipment and the equipment is monitored with thermostats that are sophisticated, and they will page the unfortunate person who, I don't know what their title is, but the IT person who needs to, who are they?
Usually lab technician.
Yeah, the lab technician. So something like that could trigger a pager to a lab technician so they can come and deal if there is any type of anomaly with the temperatures. Yeah.
They also kind of kick on the air conditioning when it's too hot, and if you're in there and you're going to freeze in the seat of your breath, it's too hot.
Right, that sounds like a lot of fun. One other thing that happens is when it gets, I forgot how it works, but sometimes when the network equipment here has to be cooled off, it triggers the air conditioning in this room becomes impossibly cold. But anyhow, I digress. All right, so let's type this program. You saw the original, and let's see, you're clear what we're doing. Now let's go ahead and do it in Python hands-on. We'll start our idle, your idle. Has anyone watched Silicon Valley in this? Oh, you should watch it if you can. I was reminded of the scene where they had their social network transformed into a box and then put in the other storage area. You should watch it if you're in tech. I think you'd enjoy it. And I think they have them free. They're free now for. We can watch it. I forgot how it goes. But, so I'm trying to find the mouse. I think they post them for free, so you can watch them without having to subscribe to HBO. You really should, Brian.
I've been meaning to.
Yeah.
My friends are like, kind of excited.
Yeah, you really should. I've tried to show snippets of it in some classes, but it's like I always forget how inappropriate it is, and it's just it's really not something.
Okay,
to
then
show
I'll
here.
watch it now.
All right. From this to now. All right. So let's see here. No, I mean it is very realistic, and I have a friend whose husband runs actually a former student and a friend whose I guess husband runs a startup, and he said that it's so realistic that he can't watch it because it stresses him out.
I just love how they portray the CEO of that big company. Really, yeah, that really CEO.
Oh yeah, that was just.
I love how they make his ego just out of this world.
Yeah. He's some character. Let's see, this is chapter 7. So we can program, sorry about the delay, save this as convert to second version. Convert cells to Fahrenheit. and issue heat and cold warnings. All right, so def main. So CS is going to equal to float of the input temperature Fahrenheit is going to be 9/5 times Celsius plus 32. And then print. The temperature is okay, right. So far the same as before. Now we're going to add warnings for extreme temperatures. And this is how we're going to write our flow chart now in Python. And you can see how the keywords change color. If Fahrenheit is greater than 90, colon, print, it's really hot out there. Careful. And if doesn't be sure to dress warmly. Okay. So the syntax, as you can see, is the if, and then this is the condition we're checking. And what we're checking is, in this case, if Fahrenheit is greater than 90, but what it checks is if the statement is true or false. So it always is going to come back to a true or false Boolean statement. And you can see you have to use the colon and then the indentation, and all the lines that are indented under the if statement, they're going to belong to the if statement. Right now we just have one line each, but it could be multiple, and that's how Python would know what goes where. And then the second if statement is the case here. So let's try this out. $25. All right, so when you have conditions, you want to check more than one value, because again, your program is going to split in different paths. And in this case, 77 doesn't give any warning, and that's what we expect, correct? Because it's in the range. So let's try it out with, let's say 105. Or, if this is Celsius, Celsius is doing pot of water and hotter. So how about 40? 40 Celsius is 104 Fahrenheit. So then, sure enough, we get the warning. And now let's try this one more time. And by the way, maybe some of you are wondering, we have to restart the program. How could we make this so that we get prompted more than once? And we can use a loop to make this happen. And we're going to go more into loops later in the class. But you need a loop to keep on prompting the user until a condition is, again, is no longer true. And then you fall out of the loop. So for now, however, close this and let's try with the third possibility, which is if it's very cold. So if you have 0 Celsius, it's 32 Fahrenheit. Oh, so we need colder than that. Okay. So we'll try -5 or -10 even. And then that's 14 Fahrenheit and that works. Are we good with this example? Any questions, comments? All right, so here is the syntax in a summary form. If a condition, then we execute the body. And again, the condition has to be evaluated to either one of two values, true or false. So here it has to be true, so we can go in the, so that the program flow is going to fall in the body. If the condition is false, then we're not going to execute the lines of code inside, right? Okay. And also to point out, the body can have one line, like we had in our example, or multiple lines. Okay. So we talked, if the condition is true, then we execute the statements of the body. And what we didn't talk about here is what happens next. After the body is executed, then control passes to the next statement of the program, right? So similar as when we had a function, and then the function body gets executed, and then control returns. The same happens here. After you finish executing the loop, the if statements in the body of the statement, then control returns to the next statement in the program. In other words, if we had put another line out here in our program, it would execute as well because it would be outside of the loop. So do we need to, should we demonstrate this, or is this clear just by talking about it? All right, maybe we'll do it. Okay, so this if statement belongs to the if, and then if we go back to the main, now we're no longer in the if statement, so now we can print we are now outside of the if statement. And again, the indentation is Python's way to keep track of where you are. So if it's, say, -15, and we're always going to get this statement no matter which code path, because it's outside of the if statements, right? Okay. And then what happens if we encounter if the condition is false, then the body is simply skipped, and then you will continue to the next line, right? So if none of the conditions were true, it will just go to the next line out after the if statement. And again, you can have multiple statements or one, depending on the nature of the program. Okay, and so this is what we would call a one-way decision. We can only make one decision. We made two decisions in our program by using two if statements, but they're one each. And the reason I'm saying this is because now we're going to talk about what if we needed to have multiple statements, right? And so the condition, I already mentioned that it is going to evaluate a Boolean, but what we actually call the line of code where we set Fahrenheit greater than 90, this is called the relational operators. So the relational operators are our way to compare values to determine if something is true or false. That's the simplest way. You can also get more complex, and I'll talk about it in the next chapter. So for example, these are the available relational operators in Python, and they will correspond to the ones in math. The syntax is mostly the same. And what kind of comparisons can we do? Well, we can check if something is less than something else, right? We can check if it's less than or equal. So if we wanted to say we want to include 90 in our decision, then we would use actually this one, greater than or equal to 90. Should we try this to see the difference? Okay. So if we go back to our program, and say 90 in the current way, then we get 190. This is very, oh, sorry. So, okay, that's not what, I didn't want to show you this. I meant to hit the Fahrenheit 90, not the Celsius. All right. So what is 90? 30 what? 30. Oh, this will be interesting. Okay. 32.5. This might not, because they're floats. 90.5. Okay. Well, 32.5 is going to result in 90.5, which is higher, and therefore it's showing here. Christina, yeah, I don't think we can get this. So just take my word that if we hit exactly 90, based on the statement we have here, it would not trigger the warning. But if we wanted to trigger the warning, then we would make the change by using the relational operator greater than or equal to. And then when you make this change, then it includes the value. One thing I like to do when working with ranges like that is to draw a line, and then right now we have a range between 30 and 90. And the way our program is written, these are not included. So if I just said greater than, less than 30 or greater than 90, then these numbers would not be included. But if I wanted to include it, I would say greater than or equal, and now my condition will check. So this is important because of the logic, right? The logic would be different based whether you use greater than or greater than or equal. And also, there is one other operator we have not used yet, which is the not equal. So if you see the exclamation mark equal, that means not. So it's going to just flip the value. Let's say if it was true, make it false, and the other way around. And the other one that is worth pointing out is the equal to. In math, we use the single equal, but in computer science, we use the single equal to do what? We use it as an assignment operator, and therefore we need to use something else to check for equality if two things are equal to each other, and therefore we're going to use the double equal to check. And it's a common common programming error to use a single equal instead of double equal. And if you now, do you remember the why robots killing us? I showed you this cartoon or cartoon. Do you remember what happened there? We used an assignment instead of. Should I show it again? Would you like me to show it again or no? It's okay if you don't want to. No? All right. But it was interesting, and it's also posted by my office because it shows exactly the error if you're using a single equal instead of double equal. It can have big implications. A lot of the time, actually, the syntax will not allow you to do it, but if it does allow you to do it, it will be a big logical error. Okay, so these are what we are going to work with: not equal, equal, and then the greater than or less than, and greater than or equal to. All right, so don't make this mistake. Sometimes I make it just because, I know it and I'm in a hurry and I make it. So just be careful. All right, so far we have tried out numbers, but you can also compare strings. And how are strings compared? They compare it based on something called their lexicographic order. And what that means is, what is their Unicode value? Did I show you, I believe I showed you the Unicode table and how each letter has an assigned number. And so these are the numbers that are used to do the lexicographic comparison. And the uppercase, for example, comes before the lowercase in the Latin alphabet. Therefore, if you're checking, if you had uppercase B, it would be greater than, right, than the lowercase. In those conditions, they're called Boolean, and it's a fun fact. They are, in my opinion, named after the English mathematician George Boole. So he wrote a lot of really fascinating papers about algebra and Boolean algebra, and his name stuck. And apparently he was married to a Victorian lady who believed in, I don't know what it's called, maybe, what is the thing where, let's see, when you think that if you use a small amount of something, it produces the result, homeopathy. And he got very sick, and she was under the notion that if she put like wet sheets over him, it would draw out the cold and heal him, and it actually killed him. So it's a very, I don't know why everyone is laughing, but unfortunately, his life ended early. I guess he was a quite remarkable person and also a very nice person. I read a book about him. All right, where was I going with this? All right. Okay, so the Booleans again can have a value of either true or false, and in some languages, instead of true or false, they're going to have a numeric value of 1 or 0. And you should remember that 1 always is going to represent true, and then 0 is going to represent false. So sometimes that's what is going to check if it's 1 or 0, and it means true or false. Let's go ahead and try out these little examples here together and see that the results are printed out as true and false. And by the way, in Python, they're represented with what we call literals with an uppercase, true or false. So do a little tests. I don't think I need to do those with you. I'll let you do those. Just do them from the shell. So I think I said that the capital or upper greater value, they're actually lesser value because they come before. So the capital letters come before the lowercase, therefore they have a lower number associated with them. If you want to see the numbers, you can just look at the Unicode table, and they'll be represented in decimal and also actually first in hexadecimal and decimal.
Oh, next week.
It is not very-
Yeah, I'm good.
Okay. So this shows comparing numbers or and now we reach a topic which is seems very confusing, but I don't know why, so I'll try to make it clear. So you know how we have the main in our programs, and we can run our program as a standalone program with the main, but sometimes certain programs can function both as a standalone or as a library that you can import into another program. And so we can use a condition so that Python knows whether it should run the program as a standalone or treat it as a library module, right? Okay, so as we know, we run some directly, such as the scripts. Sometimes we import them. So we have worked with a couple libraries, such as the math library and the graphics library. And now let's take a look what if you wanted to be able to do both. So create a hybrid program to run both in a standalone mode and as a library. Okay, so we know we have a main included in our program. And essentially what we're going to do is we're going to create a condition. If it is the case that the program is main, then we're going to run it. If it's any other one, we're going to treat it as a module. So this is the idea. And the reason this is possible is because Python creates this special variable with underscores name. And this is supposed to be the name, or not supposed to, but it is the name of the imported module. So it always will create this variable. And now, because of the variable, you can do a condition and check if the name of the variable is main, you know, you want to run the program. Otherwise, it's a module. And what you can do is, you can even type. So right now, so for every program, there is a name variable. So right now, if we go to our shell here and type name, you can see that the variable currently holds the value main because that's our program. And if we had a module, it would hold a different name, right? Okay. And so therefore, you can add those lines, and if you see these lines, you're going to now know what they mean. If the name is equal to main, then run main. And that's how we use decisions to run the program. If it's main, otherwise it's a module. Okay.
How did you get, I'm not getting that dot.
It's a double underscore, 2 underscores. Okay. Yeah, so if the name double equal, we're checking for equality main, then run the main. Were you on the name to display the value? No? Okay. Huh. Have anything in the shell? Did you run program?
No, I did, I was just didn't, I couldn't see that it was two.
Okay. Hearing issues? You are? Okay. Two underscores.
Before and after.
Yeah, 2 underscores before and 2 underscores after. No, you need one more on your side.
Call it Denver.
So underscore.
Denver. Double underscore. I was thinking about it.
D-U-N-D-R.
Yeah. That's what it stands for. Yeah. I was just reading about it in this book. It's called Blue Python, and so they kind of give you stuff to help you get more fluent. That's what it said. I was reading last Tuesday.
All right. So next up, we're going to look into working with multiple decision making, but I actually don't like using the example with a quadratic because I think it distracts us from what we're trying to do, because you have to pay attention to so many other things. So instead of that, we're going to do a couple exercises from the end of the book together, which will allow us to illustrate multiple if statements. But let's take a look at, for example, here, well, I guess I don't want to go with this example, but I'll show you a statement where if we have an if, and then we can also have an alternate condition with else. So this is a two-way decision. Now, if something happens, if certain condition is true, then we're going to execute the statements. Else, we're going to execute the other statements, right? And also, maybe I should talk about this. It seems like you get the point, though. Essentially, you're going to check for each step of the way if the condition is true, and if it's true, you follow this path. If it's not, now we have an else. So else is going to be everything else, any other except for the case that it was true. And you can have also not just two decisions, but sometimes you may need to make multiple decisions. In fact, we are going to look at what if you needed to convert a numeric grade to a letter grade or the other way around. So we have, A, B, C, D, E, F, right? So we have to make 5 decisions, not just 1 or 2. How would we make this work in Python? We're going to make it work by using the elif statement or multiple elif statements. Okay? And so this is what it looks like. And you can use as many as necessary and check for as many conditions as necessary. And then you always, well, not always actually, but you could also have an else, which is the default. So if none of even though you have 5 conditions for the grades, but maybe the user entered Z, then what would you do? You can have an else there, and then instead of just being unclear what's going on, you can say invalid grade, for example. Okay, so let's take our first break, and then when we come back, we're going to do a couple examples using the more multi-way decision making with Python. You come always so prepared with food. I need to take.
I have to here since like 8. I'm sure you are too.
No, I didn't come to tomorrow. Аз сега ще отговорим.
Напиш какво ми отговори.
Разбира се, ти ще си виновен на метеоролог, така че изобщо не се прави. Ти си виновен, че изобщо не се прави. All right, a couple more minutes. Okay, so let's take a look. Let's work on exercise 1 on page 238 in the book. And the exercise is many companies pay time and a half for hours worked above 40 in a given week. Write a program to input the number of hours worked and the hourly rate and calculate the total wages for the week. And I haven't showed you how to do this yet, so I will do it with you, but maybe just give you a couple minutes to just think about the problem. And then we can do it together. Maybe we can draw ourselves a flow chart. And there's a flow chart. So the decision is going to be based on what? What are we looking here? What was? How many hours? So is the hours, so hours. Hours, 40. Okay. If the hours are greater than 40, then it's going to be and otherwise, if it's less than the pay is going to be the regular pay rate. Exactly. And then we're also taking in two values, hours. We need to, in our IPO, if we look at it in a different way, for the input, we're taking the hours and the hourly rate. So hours, numbered hours, and number in the rate. So do we have everything we need to calculate, Stefan?
I think it should be exactly this because actually in my company they pay like this, but they pay time and a half only the hours that are above 40. So 40 hours they pay the regular. If you work 42, they pay time and a half for 2 hours only. For those 2 hours and how you right now it is going to count that everything that is more than
40
hours, it automatically will count the whole 42 hours time and a half.
Right. So we need to
Yeah,
do this differently.
We have to calculate only the
Very good.
difference between 40 and.
That's correct. So let's go ahead and revise this. This is great. So go ahead and what you're saying is that we're always going to have the regular pay. We're not actually starting with two decisions, okay? So how would we express this then?
Well, 40 times pay plus.
So we're going to have so actually what we're saying is we always go to, by the way, this doesn't lend itself greatly to the flow chart, but we're always going to have pay up to 40.
Hours, yeah.
Pay 40. If pay is less than or equal to 40, we always have that. And then what are we going to check then? if there are more hours than 40.
Yes.
And then if there are more hours than 40, then we're going to add, as you say, the hours over 40 times
No, it
0.5
should be-
and then add it
Yeah,
to.
it should be the hours minus 40 multiple.
Times rate. And then down here is going to be the addition hours, the total hours minus 40. So it's going to be hours minus 40 times rate.
1.5. Yeah, the rate.
Rate times 1.5. Okay, there we go. So I think now we can work from this to write our code in Python. Yeah, okay, so you can also take a picture of this, but let's write a program. Yeah, let's create a new file so we can save it. So let's see here. Close. So save as overtime dot py. All right, so this will be overtime pay, overtime.py, calculate pay and overtime pay. And then we have our def main. Now the first thing we need to do is ask the user. Well, actually, the first thing we should do is print reading. So this will be the weekly pay calculator. And then the hours is going to equal to float of input of enter hourly wage. Sorry, enter hours work. Work. All right. Then the wage is going to equal to a float of the input. And again, we just discussed why we're using the float of input here. It's the same reason. We want to convert those strings to numbers. Enter hourly wage. We have our input, and now we're going to say if hours greater or equal to 40, less than or equal to 40, pay is going to equal to hours times the wage. Else, make sure to have your semicolons, the colons. And with the else statement, you don't check a condition. It's just anything other than the previous condition. So note that with the else, we don't have a condition we're specifying here. We're just going to say else, the pay is going to equal to pay times the wage plus hours minus 40 times 1.5 times the wage and then we can print the weekly pay is, and we can do some formatting here. Since that's money. So this is going to be a curly brace, dot, and then close the string, dot format, pay. And then we can use our newly learned if main equals main. Main. So let me test this real quick and I'll let you finish. See if everything works. No, okay, pay is not defined.
Does the income to the end one at all?
No, so this will be the same level as the main. So let me see why it doesn't like the pay.
A is in the,
Um,
Yeah, it wasn't defined.
yeah, to the,
okay, I know why. You guys see why? Because I need to actually move the print one line over, that's why. Okay, test again. Okay. This was just a typo. All right, then now it works. And by the way, I know you see me do a lot of typos, but in a way, I just let Python do this work for me. So that's kind of how I do it. And then instead of having to look for it, it will tell me there's a problem. All right, so now we have our weekly pay calculator. So let's enter 42 hours at $25 an hour. Still not liking the pay. Let's see. Now, why is that? Oh, I see why. Okay. Again. 40, 25. And there you have it. Okay. So I had a pay here, but it actually should be the hours. Run this again on a clean output. So 43 or 45 or 25. And there is the output. Okay. So if you get an error about pay, I hear a typo here. This is supposed to be the 40 hours, not pay again. All right, let's make sure this works for everyone before we continue. And do you see how we use the if and else statement now? Right, so we have a now what we call two-way decision making. Change the pay is equal to the 40 hours times wage, not pay times wage.
I'm still getting an error.
Let's take a look. Oh. Okay, so that thing is the print statement, you need to push it one tab over. So that it's inside the name, that's all. It's not.
Oh, I think that's
You
all.
don't have the closing.
Just like how they do it.
Okay, yes, so remember just.
Yeah.
So in this case, we just use a control, but the reason we do this is because if you have a program that is not the main, then you can use it as a module, so you can create your own library to import it. And then Python is going to check, this is the underscore name is the value, it's a variable that Python creates. If the variable is set to main, then it will execute the program as a main. But if it's something else, it will as a module, and it won't just start executing. Unless it's important to the program. Okay? Yeah. It looks like it is, so it should be flashed, but you have, just so you need to have a space between the words. Huh? And it's dark. And it has to be double underscore. I think right now it's the same. Could you underscore on both sides? Not the same on the other side. But you name the group.
Oh, I see.
No?
Okay, that's.
So these are, you guys made all the mistakes I made except for that one.
The braces?
Yeah.
I thought they were at first, but I.
They should be.
more or less.
We're using, remember, it's hard to see here, but if you're using the formatting here, these are curly braces, not parents. So if you're getting an error, it might be because you're using parents. There should be curly braces around the formatting. And so this is an example of using an if else. Do you need a few more minutes with this or? Okay, a couple more minutes and then we'll do another example with a elif. Take it to the next level, as you say. More than two? Well, because the previous, you have to have here, this have to be curly braces, so I don't know if that's why it's showing them.
Oh, there it is.
Yeah, around the, right there.
Yeah.
Yeah. I'm getting the time, where are they on the keyboard? So let's try and see. Oh, maybe your main is way too inventive. I'm just going to want it one there. Just delete this and let's start it again. Just delete. Okay, so then quote, double underscore, underscore, main, underscore, quote, comma. Maybe it was a brilliant.
Yeah.
I don't know. So there's the main maybe. bracket, okay, now return, and then type main. Oh yeah, you're missing a second, good idea. You need to close one more bracket there. Maybe that's why it knows.
Yep.
Yeah. All right.
Yes. Thank you.
Let's do one more. Do you have a question? Yes. Okay, so I am going to talk about this one more time because a couple of students asked about it. What is the meaning of this line here? So, okay, so here is what's happening. Sometimes we want to be able to use our programs as library modules. Does this make sense? Like we want the graphics is a library. It doesn't run by itself, but we import it and then we use it. And if we wanted to do something like that, then we would give our program our function a different name than main. Right now, actually every time Python creates a variable called _name, and then stores the name, the value that represents the name of the main program. If it's main, then it means run main, and we're going to run it as a standalone program. If it's something else, then we're not going to be able to run as a standalone program. We're going to be able to include it as a module in another file to use it. It's not something we have actually worked with, so maybe that's why it doesn't make sense. But the reason we do it is just as a good practice, so that we can separate running modules versus standalone programs. All right, let's do one more. Let's do a certain CS professor gave, this is page 239, assignment exercise 2. A certain CS professor gave 5-point quizzes that are graded on a scale where 5 is A, 4 is B, 3 is C, 2 is D, 1 is F, and 0 is F. Write a program that accepts a quiz score as an input and uses a decision structure to calculate the corresponding grade. So think about this for a couple of minutes, and we haven't learned how to do this in Python yet. I'm about to show you. But can you tell it's going to involve some kind of decision making, multi-way decision making, right? Because we have to account for 5 different. And we do this great program in every beginning programming class in every language. So you'll be seeing it again in Java and in JavaScript. Okay. So a new file. Quiz.py. Okay. So I will not draw the flow chart, but you can imagine that it's a similar. We have to make different decisions, and based on the condition, we have to have different results, right? But the first thing we need to do is first of all, let's write the name of the program and what it does. Quiz grader using decisions. We're going to have a main. And the first thing we'll do is to ask, to have a greeting here, quiz grader. How many inputs do we have? Read the assignment and tell me, please. Well, yes, but there are 5 variations of one input, really. I'm sorry? I think maybe my question is not. So what I'm getting at is that we just have one. We need the user to only do one input, which is a number, and that number can be 6 different possible choices. But the only thing we need to ask the user is one question, and that is, what is the score, right? So we have one input, and then we're going to set the score variable to equal to float input. And again, we're dealing with numbers, so we have to convert the string. Enter the score from 0 to 5. Elif? Yeah, we're going to do elifs. That's exactly right. That's what we're about to do. Okay? So then once we have this, then we're going to create our decision. If score is less than 2, so now what you can do is you can tell me, read the assignment again, and if the score is less than 2, what should the grade be? So we can handle both the 1 and 0 by assigning it the value f, because they both get the same numeric, letter grade. And now, then we're going to now go and for the first time use the elif statement, or the part of the statement. This allows us, this is how we can create 5 different decision branches. Else, elif score less than 3. If it's less than 3, then the grade will be B. According here to the, so that's a great point. Correct. However, because we already accounted, if it's less than 2, then we're not going to have to worry about it. But you're right, and that was worth pointing out. Even though 1 and 0 are less than 3, we already took care of it before, so it's not going to be continuing down because of that. All right, and then we can have multiple elif statements. So the next one would be if the score is less than 4. Grade is equal to C. If the score is less than 5, the grade is equal to B. Else, grade is equal to A. And then outside of the if then else statement, we're going to print grade is great. Then I'll do if name. Again, we're not really going to send this program to be a library, but we're just practicing what we just learned here with the spec for the main function, right? So when you create your own library in module, you know how to do this. All right, let me test this real quick, see if this works. All right, almost. Okay. And then we can test it with several different values. And again, it's important if you are using condition with multiple decisions to test all the possible code paths, because you might have a mistake in one of them. All right, and so this is the multi-decision, and we have built from if. We can just have if and only if statement. We can have an if and else and nothing else, or we can have multiple decision with if, else, if, as many times as we need to, and also an else. And note that again, with else, there is no condition. The else is just anything else other than.
So you could throw another condition in there to validate the form, to validate it too. So like if somebody entered like a negative number,
That's correct.
or a
You can
number
say,
greater than 5, you could be like,
this is invalid.
yeah.
What you could do is you'd say that's right. So you'd say, for this, to create this kind of condition, we need to use the compound logical operators, which we use next time. So the logical and or, and you can say if the score is less than 0 and
Print this,
Right.
print not a valid score.
not a valid score. If it's less than 0 or so that's 5. So if it's less than 0,
Or
less than 0 or greater than 5,
greater than 5.
greater than 5, then we're going to learn how to describe this in Python. And this is actually very common because validating data is a big part of the process. It's a bit tedious, but you do a lot of it. Okay, is this working for everyone? Okay, so then we have time for one more activity. Okay, this. We're going to talk about exception handling next time we meet, since it's somewhat separate topic. All right, but how about tonight we try to accomplish one more thing, which is if you have a problem where you're given the assignment to determine, you're given 3 values, so the user inputs 3 numbers, which one is the max number of the 3? And so how would we write a program to do this in Python? And there are a couple different ways you can go about it, but we need to essentially check, we need to write an algorithm to determine which of the 3 numbers is the largest. So we're going to go a little bit through the design process here and then write the solution together. Should just have enough time. So we know this much, right? We all know we need to grab 3 numbers. Eval is an easy way to grab input, not for production. And then we have some missing code, but we know we need to plug something here and then print out the result. So we now need to figure out this part of the program. So I'm going to, you can start thinking through this, but essentially we can attempt this approach, which is to check the numbers, if this one is bigger than this one, and this one is bigger than this one. And then this is not necessarily going to always work out logically. So there is a logical flow here if we take this approach. And I will let you, reading through it, or maybe it seems like you're interested. Okay, so maybe we should review this. So we ask ourselves 2 questions. Is it logically sound? And secondly, is there a Python syntax we can use to make this work? And surprisingly, in Python, it does work. In many other languages, it would not. But you could do this kind of compound condition in Python. If x is at least as large as x2 and x3, then x1 should be the max val. So what if we have 5, 2, and 4? So 5 is larger, but 2 is not larger than 4, right? So maybe the better way to do this is to separate them. We don't need to be stuck with using a compound statement. We can separate them in two different statements. If x1 is greater than x2, then we're going to compare x1 with x3, right? And now we can make something like this. If x1, and we don't know yet how to describe end in Python, but we will learn. Then x1 is the max val. Else, if x2 is greater than x1 and x2 is greater than x3, then x2 is the max, and then otherwise the third one. And so if we were trying to extend our program in a different way, which is to compare more, to have more values, then this can become quite tedious. So maybe we can look at a different approach using decisions. How about something like that? And this is also going to allow us to learn something new, which is that you can nest if statements inside other if statements. So nesting is allowed. And so this will provide us a decision tree solution, and we have time to write this and test it out for ourselves. So let's go ahead and do one more program together. And then I'll show you, it turns out that there is a Python function max, which would do the job for us. But until then, let's do it the hard way. Let's see here. All right, so you can write the program in a file again. Just a second. So start a new file. What is this? Save as. And so we're also going to do something else here, which is we're going to extend our program to be flexible as to how many numbers you want to compare. So go ahead and write max_n.py. Find the max of a series of numbers. Okay, so n is going to equal to an int of the input of how many numbers are there. Actually, all right, so and then set max to be the first value. And so before I continue, sorry. So the important point here is that we sort of just went through this pretty easily, but this is the type of program that is very small and a few lines of code, but it would take a lot of time probably if we just had to sit down without help and think about it. So coming up with a solution like that is not exactly easy to do of your own. It requires, some thinking. And then when you put it together, then it's easy and elegant. All right, so max is going to equal to a float of the input. Enter a number. And now we're going to compare n minus 1 successive values. So this is a pretty cool solution. We're going to use a range for I in, yeah.
Sorry, do you need a bracket between input and enter?
Yes, thanks. There you go. For I in range, in the range of n minus 1, x is going to equal to a float of input. Enter a number. And now, if x is greater than max, we're going to assign max to equal to x. Okay? And pretty much that's it. And then we print the largest value is max. So that's a pretty elegant solution. Can you tell? It's really very compact, but it does the job. But it turns out there is one solution that is even shorter than that. And let's make sure this works for everyone, and then I'll show you one alternative solution. Any questions? Do you see how we're using this, the range? So the range is going to go up to the number we enter. And then it just, once you're in the loop, then you just replace max with any input that is greater than the current max. And that's the solution right there. All right? Yeah. Sure. Take the time to test it with multiple values, multiple numbers. So I have one more solution to show you, and then it's going to be lab time, and then you can maybe continue investigating this problem and ask any questions, but I would like to show you one other thing here. And we can probably just do this in the shell. So let's see. So let's do a def main in the shell. x1, x2. So we're going to use the simultaneous assignment is equal to eval of input. Please enter three values, three values. And then we're going to print the largest value is. And so it turns out that Python has a built-in max function where we can pass in x1, x2, and x3, and it's going to do the work for us. All right, so you tell me which solution you prefer. The easiest one? Yeah. Yes. If you have a built-in functionality, it's, well, sometimes it's a pain to use built-in functions, but this one is easy now. So that's what I had to show you for tonight, and now we can have lab time, and you can work through this some more or ask me any questions you might have. All right?